Let's talk about silver, the shiny metal in your jewelry, coins, and even your phone. But silver's story doesn't start polished. It begins deep underground, hidden in plain-looking rock, that necklace or coin. It was once trapped, mixed with other minerals, waiting to be freed. Extracting silver isn't easy. It's a gritty, high-stakes hunt, not a simple pick and choose. Miners and machines blast, crush, and sweat to bring it to the surface. The process is a wild mix of brute force and science, transforming rough rock into gleaming metal. We'll follow silver's journey: deep mines, roaring trucks, crushing machines, and fiery furnaces. It's a process refined over centuries, but at its core, it's about wresting treasure from the earth. After seeing what it takes, you'll never look at silver the same way again. It's more than metal, it's a story of grit and glory. Let's dig in. Silver doesn't just sit around waiting to be picked up, it's locked in ore, rock with enough silver to be worth mining. You'll find it in veins, deep cracks in the earth, often alongside gold, lead, and copper. Major silver mines are in Mexico, Peru, China, and Nevada. Getting ore out is called hard rock mining, drilling, blasting, and carving through solid stone. Miners drill holes, pack them with explosives, and blast the rock apart. It's loud, dusty, and dangerous. Miners are true heroes, braving the earth's depths. Each blast frees tons of rock, but the silver is still hidden inside. The result? Piles of broken ore, each chunk holding tiny, nearly invisible silver particles. This is just the start. The real work is only beginning. From here, the ore's journey to becoming pure silver is just getting underway. Let's see what happens next. Once the ore is blasted loose, it's time to move mountains, literally. Enter the haul trucks, massive machines, each carrying hundreds of tons of rock. These giants rumble day and night, driven by skilled operators, ferrying ore from mine to processing plant. The journey can be miles long, over rugged roads built just for this purpose. Each load is a step closer to silver's transformation. Without these trucks, the operation would grind to a halt. At the plant, the ore is dumped, ready for the next phase. The air is thick with dust and anticipation. These rocks are about to get a serious makeover. Now, the real transformation begins. At the plant, the silver is still locked in rock, so it's time to crush and grind. First, giant crushers break the ore into smaller pieces. Jaw crushers and gyratory crushers do the heavy lifting, turning boulders into pebbles. Then, grinding mills. Huge drums filled with steel balls pulverize the ore into fine powder. This relentless process frees the tiny silver particles from the waste rock. The goal: create a fine pulp so the next steps can extract the silver efficiently. The finer the powder, the easier it is to separate silver from everything else. By the end, the ore is a soupy, fine-grained material, ready for chemistry to work its magic. Crushing and grinding are all about unlocking silver's potential. Now it's time for some chemical wizardry. Let's see how science snags the silver. With the ore ground to powder, it's time to separate silver from the rest. Enter froth flotation, a clever chemical process. The powdered ore is mixed with water and special chemicals called collectors. These chemicals make silver particles hydrophobic. They stick to air bubbles, not water. Air is bubbled through the mix in flotation cells. Silver attaches to bubbles and rises as froth. The froth, rich in silver, is skimmed off, leaving waste behind. For some ores, leaching is used. Chemicals like cyanide dissolve silver, which is then recovered from solution. Both methods use chemistry to pull silver from the crowd. The result: a concentrated silver-rich material, ready for the next step. The waste is left behind, the treasure moves forward. Next up, fire and fury, smelting. Now the concentrated silver heads to the furnace for smelting. Smelting uses extreme heat, over 2,000 degrees Fahrenheit, to melt the concentrate. Fluxes are added to help separate impurities. Inside the furnace, silver and other precious metals sink, while lighter impurities form a glassy slag on top. The slag is removed, leaving behind molten silver, often mixed with gold and traces of other metals. This product, called d'or, is about 95–99% silver. D'or bars are cast, each weighing hundreds of pounds. They're much purer than raw ore, but not pure enough for most uses. Smelting is dirty, dangerous, and essential, turning concentrate into nearly pure metal. The next step: refining to perfection. Let's see how silver becomes truly pure. D'or bars are good, but for electronics, coins, or jewelry, we need ultra-pure silver. Enter electro-refining, a high-tech purification using electricity. D'or bars become anodes, pure silver sheets are cathodes, both submerged in a silver nitrate solution. An electric current dissolves silver from the anode, which plates onto the cathode as pure metal. Impurities fall away as valuable sludge or stay dissolved. Over time, the cathodes grow thick with 99.99% pure silver. This pure silver is melted and cast into bars, coins, jewelry, or industrial parts. From dull rock to gleaming treasure, every ounce tells a story of grit, fire, and ingenuity. Silver's journey is a testament to human skill and determination. Next time you see a silver coin or ring, remember the epic adventure behind its shine. That's the magic and the reality of silver.